So good afternoon, everyone, and welcome to this iMOVE webinar on cooperative ITS. I'm Ian Christensen. I'm the Managing Director of iMOVE, and I'll be your host for today. But before we get started, perhaps, and while people are still filing in, we'll go to the housekeeping points first. So please keep your microphone on mute if it hasn't been already put on mute. And when you thought of your good questions, could you use the Q&A function, which can be accessed in the icon bar at the bottom of your screen. If you type the questions in, we will endeavour to deal with them in a timely way. That'll either be at the end of each presentation or at the end of the session. We've allowed plenty of time in the webinar for questions and answers, so get those questions coming. So, cooperative ITS. So it's a personal view, but my thinking is that cooperative ITS is one of, if not the most important emerging technology for the management of traffic. And it's because it's so important, it becomes necessary for Australia and all of its transport traffic management authorities and operators in the transport space to develop an understanding of what CITS is, what it does, and how they can benefit. In particular, there are strong safety benefits, there are traffic flow benefits, and there are mobility benefits for individuals. So, but CITS is a system, and it requires all the parts of that system to participate together and speak a common language. That's going to require a fair degree of cooperation between travellers, motorists, pedestrians, traffic managers, and between jurisdictions nationally. So because CITS is such an important technology, it's an aspect that many of iMOVE's participants have been and continue to be active in, and none less in that space than Melbourne University and their AIMS testbed. So today we're going to hear several presentations, partly about work that has been done on the AIMS testbed, and also about some current work that is currently being done by the Toyota Lexus people on the AIMS testbed. And I would invite you to think about how you in the audience can learn their experiences, actually take advantage of the learnings that they're about to present to you. So to start the process, I'd like to introduce our first speakers, which is Professor Majid Sarvi and Dr Nima Nasir. Majid is the Transport Professor and Director of the AIMS testbed at Melbourne Uni, and Nima Nasir is the Senior Lecturer of Transport Engineering, also at Melbourne Uni. So, Majid, over to you.
Oh, thank you, Ian. I also would like to thank iMOVE for putting together this fantastic webinar together, so we'll be able to talk about some of the work that Ian mentioned we've done as part of AIMS program, and also a couple of a very interesting project we did as part of iMOVE that are very relevant to this work, and we'll present together with Nima. I'm not going to go through the technical stuff. More or less, it is about 1,000 pages of document and reports that we did it together, with our partners and iMOVE. And if you're interested, please reach out and we're more than happy to provide more details. But I'm going to start the presentation now and take you through it. Hopefully, it would be interesting. First of all, I would like to acknowledge, some of the staffs and the students that work on this project, with us in Melbourne University, and also our industry partner. The name is written there, so I'm not going to read them, but there was a very, very interesting partnership with industry and government, and many people basically work on this project. So I think the first project I'm going to talk about it was a sort of, you know, transport management project where we look at the benefit and potential of CAV, or connected automated vehicle, and understand how they can enhance safety and how they can improve transport operation. So that was the lens that we used in this study. It was a 2 years study as iMOVE, a project with Cubic Transportation, with Department of Transport in Victoria, TAC as well. So we look at developing some signal control strategy for connected vehicles. So what does it mean to have connected vehicle working in transportation? Develop some proactive traffic signal control that use machine learning and optimization. And we understand that why those are very important, and provide accurate and reliable estimation of traffic flow and speed and queue using connected automated vehicle. I think this is very, very important. This is a cornerstone of any transport system management, to understand what is the flow, what is the speed, what is the queue. I think it's still that's stay very valid. I know that there's a project within the Department of Transport looking at the estimation of queue as we speak. And then looking at enhancing traffic safety at network level. So what does it mean to improve safety? And evaluating different technologies, you know, when it comes to, you know, put them out and augment our transport system, such as, you know, where should we put loops or cameras on radar or Bluetooth, and so on and so forth. So with that, you know, I put some, you know, overview of the sort of, you know, methodology we use. You know, we look at the connected vehicle, and then augmented with existing, you know, technology such as a SCAD, and then some prediction and real-time prediction using machine learning, and put them all together in order to, you know, get the best out of our transport system through signal optimization. So that was sort of, you know, the main objective. So we have done this through several methods. I'm going to talk about just one of them here, which is called MPC, or model predictive control, borrowed from robotic system. So this is a proactive system. Is not only looking at the current system, is looking at the future system, future.
Sorry to interrupt. We only see your first slide, Majid.
Oh, really?
Yes.
Oops. So why is that? So I couldn't see anything else.
No. Okay, now it was shown.
Sorry, guys. Okay, so maybe I shouldn't go to the presentation mode.
Now we see it.
Okay, so, all right. Sorry for the interruption. So I was mentioning about this and then got to this. Can you see it now?
Yes.
Okay.
Yes.
So as I mentioned, is a sort of, you know, system that use current and future status of the transport system, and then optimize traffic, and also do coordination. So you make sure that this is optimized for the entire network. So it's not local optimization, is a total network optimization, which is very important. It's data driven, and is perfectly working with connected automated vehicles. So that was what we wanted to achieve. For example, we do not need to know the OD. This is a big deal, because usually in transportation, they use very complex and very expensive modeling exercise to understand, you know, what is the OD, and then use that as a way to optimize signals. But this methodology doesn't need that, so we kind of skip that. And as I said, it used some short term prediction, for example, 5 cycles ahead, also some long-term prediction like 30 minutes ahead, and find them together and to understand, you know, there is going to be some congestion, how to prevent it, how to combat that congestion before happening. So that's very important. So it's very proactive rather than reacting to what is happening, you know, in transport system, and also has the promise of understanding incidents. So I mean, this is still a work in progress, but this is something can be you know, built into the system using you know, the data, for example, using connected vehicle data. as I mentioned, we did some predictive modeling using machine learning. To just show you one of them, we collaborated with startup Peak Hour Urban Technology, and this graph shows, how nicely we can predict the fluctuation of traffic volume, for example, or speed in the network, which is very important. If you understand this is going to happen 10 minutes ahead, then you can do something about it before it happens. Further to that, we applied this to Ames area. I'm going to just show you a couple of slides. So more or less, the Ames is a large area in Carlton, about 70 intersections. So it's not a small, it's quite large, and has all kinds of modes of transport. For example, when we deployed this methodology to corridor, this is a Queensberry Street. As you can see, the penetration of 30% of CAV, this contributed to corridor throughput improvement by 38%. It's quite large, and a reduction of congestion by 11%. And this is just purely using connected automated vehicle data, which is a quite good outcome. Looking at the network level, if you deploy to Ames network, as you can see in the screen, with 20% penetration rate, the average travel speed is improved by 10%. So everybody benefited by having just 20% connected automated vehicle moving around the network, mixed with other normal cars or vehicles. You could improve the system significantly. So that's the sort of benefit of using such a system and having connected vehicle data. For example, we're also looking at the combination of technologies. This graph shows if you combine CAV with Bluetooth, how you can predict, for example, flow in the network, which is again very important parameters to understand the behavior of the network. And as you can see, different combination give you different answers. So this methodology that we developed as part of this iMOVE project can be also used to understand what technology should be going to the network and augmenting the existing network to get the best outcome for you. For example, do I need to provide Bluetooth at every intersection, or I need to put them in certain location? Do I need to have cameras in this intersection or that intersection? So this technology can, this methodology can also address that question. I'll move forward because of the time. We also look at the safety consideration of CAV. So far I talked about the operation performance. Now I'm going to talk about the safety performance. If you bring this to the equation. So everybody knows, if you have a network like this, you would like to maximize the throughput. So you get the maximum number of vehicles going through the network. However, when you have conflicting movement, such as this one, so for sure, if you have more of the turning vehicles, you're going to have more conflict and less throughput. So the question here was, is it any sort of answers that not only improving the throughput, also minimizing this conflicts? So that was the question we were looking at, and what is the best sort of policy in this setting? So we deployed again, we developed the technology, the methodology. I'm not going to talk about it. We don't have time, but the outcome of that methodology was deployed to Ames area, as you can see in this map. And these are some of the outcome. So first of all, this is a policy parameter that you need to, discuss it. How much throughput you would like to sacrifice in order to get more safety. So that's something you can always talk about it, and this methodology can help you to understand that sensitivity. However, we found, for example, traffic efficiency can improve by 4%. At the same time, traffic safety or number of conflict could be reduced by 5%. So you didn't basically sacrifice throughput to get better safety. You could improve both of them at the same time. That was a great outcome. So if you use this kind of methodology with a very rich data coming from connected automated vehicle, you could improve safety at the same time improving your throughput. I think this is very, very important lesson that we can take away. from this practice. And last slide before I pass it to Nima. So the development methodology worked very nicely with connected automated vehicle. It looked at the network level, optimize the whole network, looking at the safety, consider it very importantly in the underlying assumption of what we have done. So safety is there as a core from the first time, from the first step. And this methodology is data-driven, get better as we get more data, and perfectly works with CAV. So once we have the connected automated vehicle data, we can use that without having any other technology, in the network, no loop, no Bluetooth, no camera, nothing. Just using purely connected automated vehicle data, we can manage your transport system. And once you get over 25% of penetration, you can do it much better with the existing system that we have in place. So I'll pass it to Nima to take you through the rest of the presentation. Thank you.
Thank you, Majid. Do you see my screen?
Yes.
Okay. Thank you very much. So we also looked at the history of crashes in Victoria. We studied the open data set of Victorian crashes for 15 years. This is a rich data set, includes information of all the crashes, different crash types, vehicles involved, individuals, characteristics, geometric design, geographic region, and also the conditions of the pavement, atmospheric condition, and so on and so forth. So we mapped these historical record of crashes with the ideal CITS applications that could address these. So we made the assumption that under ideal scenario where the message inception and reception is being made accurately and in time, and then they are acted upon effectively. So with these assumptions, we kind of mapped these different types of crashes to relevant use cases to get a sense what is the extent of benefits that we can expect from these use case applications in the Victoria network. So results basically were interesting. I mean, the extent that we should expect to be addressed by these new technologies are high, up to 80% can be addressed under ideal circumstances. However, what's probably a little bit more in details and interesting is that these benefits are not evenly distributed among different cohorts of road users and also across the geography. What's probably more interesting is that the extent of benefits vary from use case to use case and from technology to technology. So we followed the roadmap from the European roadmap to implementation. And we basically made the clear distinction between use cases that promote awareness messages versus warning messages, which require more advanced, information and advanced technologies. So with this, we basically scanned through and reviewed all the crashes over the past 15 years. And we mapped them with the relevant use cases, 8 dominant use cases that we defined for this study, starting from the simplest one or the ones that are more established, including ADAS use cases, lane keep assist, day one use cases, mainly require one-way kind of messaging and communication, all the way to a more complicated use cases that may require coordination, may require advanced detection and positioning, and also two-way communication. And then we map them depending on geography, depending on the circumstances of crashes to the historic data. So just very brief kind of summary of results. So what jumps out of this preliminary crash record study is that ADAS and day one use cases have huge potential to address about 40% of existing fatal crashes. And then when adding to that, day one capabilities and day two capabilities, we can actually reach up to above 70% across the board for all types. So again, one really relevant question and one relevant kind of observation is that with day 3, it's probably until day 3 implementation that we would see impact for vulnerable road users and mainly for pedestrians. We also observed that ADAS and particularly lane keep assist and curb speed warning basically had huge effect, especially when we consider remote and regional use cases. And an opposite trend was observed for pedestrians, especially with the highest impact and highest savings happening at day 3 for pedestrians in the CBD area, and the trend diminishes as we go to lower density areas. So in the interest of time, I would pause here and basically move on to the next step, but we can actually share the results of this study that kind of breaks down the type of crashes by road users and by severity and kind of combines the crash types with use cases. And we basically observed really interesting kind of trends and distributions, especially when we consider the day-to-day progression according to the European roadmap.
Thanks, Nima, and thanks, Majid. There was a question came through from Judo Zhong, but it seems to have disappeared a bit. Well, maybe I'll have a yes. I found it. So this is one for Majid. Regarding the simulations your team did for various CAV penetrations, how did you consider the longitudinal and lateral interactions between CAVs and human-driven vehicles?
Yeah, I think what we have done, I didn't get to the details. When we set up the methodology, we consider a bunch of data that can be used by the the algorithm. For example, if you have the GPS location of certain vehicle with lane accuracy or with link accuracy and so on and so forth. If you have a speed of the link over a certain section or over the link, and then the methodology use this available data in order to generate the outcome. So for connected automated vehicle, we assume we have the location of the vehicle with the accuracy of each lane, plus their heading and the acceleration and the speed. So that was the assumption in the methodology. So we did not really bother to consider there's going to be some interaction, because the methodology is not so sensitive to those kind of assumptions. However, this could be also considered, if you would like to take it further. But for what we wanted to do in a network level, we did not need that.
Thanks, Majid. So from past work to future work, no, to current work. Well, I'd like to go to the next step now and introduce Mario Filipovic from Lexus, who will talk about the experience they're having running their connected vehicles on the AIMS network. And Mario is going to be joined by Alex Lockie, who's the senior ITS specialist at Toyota Lexus. So Mario, over to you.
All right, we're going to try and play a video of the launch activity of our project. So I'm going to hand over to Alex. If the video doesn't work, then we'll put a link in the chat.
Thank you, Mario. I'll again, if there's any issues with the video, please let us know in the chat, and I'll click play on this, and then we'll launch into a presentation afterwards.
What could be the answer to Melbourne's traffic gridlock is now being tested on city streets. The latest in-car technology could make our roads safer and smarter, saving time and lives.
Historic Carlton is now home to the road safety system of the future. An elaborate network of smart sensors has been installed, allowing cars and infrastructure to communicate.
This is a very big step forward to bring a connected vehicle to Australia, so this is really exciting.
Car manufacturer Lexus has partnered with Melbourne University to accelerate testing of connected vehicle technology. The devices track individual movement of pedestrians, cyclists and traffic, sharing real-time information with drivers.
Caution, traffic jam ahead.
Could get an emergency braking happening, 5-6 vehicles ahead of you that you wouldn't normally see.
The aim is to pair smart cars with smart cities to help alleviate traffic jams and prevent accidents.
We're still losing more than 1,000 people on our road every year, and this technology can bring that 1,000 almost to zero.
State governments across the country are gearing up for this next generation of safety.
If we save just one life with connected and autonomous vehicles, as far as we're concerned, that'll be worth it.
The in-car devices are small and affordable. The technology is already available overseas, and it's hoped they'll be installed in cars here from 2024. Jackie Quist, 7 News.
Okay, so I'm going to move into our PowerPoint slideshow from there. So again, if there's any issues with that, just let me know in the chat. My name's Alex Lockie, as I've already been introduced. Mario and I work in the Cooperative Intelligent Transport Systems and Advanced Vehicle Safety Group at Toyota Motor Corporation. And I'm going to run through some of the things that we've been doing in the AIMS precinct, as well as some history of our past trials, and then I'll hand over to Mario for a bit more of an in-depth look about what we're actually doing within that AIMS activity. So we've been involved in a range of CITS activities with the Queensland government and with the Victorian government over the last few years. Developing our systems locally for both urban, rural and test track locations, and also partnering with some international technology leaders in the field. For example, Telstra, Coda Wireless, WSP, Capch, etc., but also with other companies on network side, such as Ericsson, and on device side, so Continental, Magellan Systems, Qualcomm, and so on. And we've been trialling both dedicated short-range communication, ITS G5 technology, and LTE V2X, so Cellular V2X. And part of the background for this is that in Japan, we are in production with Cooperative Intelligent Transport Systems since 2015. We have over 250,000 vehicles sold with the system installed and operational. It's fully integrated into the vehicle. So you receive warnings about safety situations through what we call the multifunction display, which is a small screen that you view through the steering wheel or in a head-up display in front of the driver. The initial data from those deployments is quite good. We believe there is a 38% reduction in near-miss events when turning right at cooperative intersections. That's generally on an unprotected right turn in Japan. The built environment obviously in Japan is quite different to Australia. There's much less visibility. The setbacks from the roadside are much shorter, so there's less ability to see what's coming. And so there's an extensive sensor array that supports those use cases. Another thing that has been trialed is the alerts for emergency services vehicles, and that is reducing response times for emergency vehicles in places where this is operational by 7.7%. So there's considerable benefits from the deployment of the technology. And among those other use cases that we have there is cooperative adaptive cruise control for sort of the beginnings of platooning, tram alerts in places where there are trams. Some cities in Japan have light rail, particularly Hiroshima. And other things like whether a bus is dropping off and picking up passengers. Now, these scenarios, of course, vary from city to city and from Japan to Australia quite significantly. So we then are participating in those trials to understand what the Australian situation is. We're using a different frequency here. We're looking at 5.9 gigahertz band. In Japan, it works in 700 megahertz. There's a military user in the 5.9 gigahertz band. And so the radio performances are necessarily different as well. So to that end, we've been trialing these technologies in Australia to better understand local needs in that area. And a big part of that is what we're doing in AIMS. So we want to test the applications that we're proposing to bring to Australia, as well as the rules and readiness for CITS. So CITS is not just a matter of making cars talk to cars. That's within each automotive brand. That's a relatively I don't want to say simple thing, but it's not very complicated in terms of data streams coming into your vehicle. However, when you're working with CITS in a more open ecosystem, interoperability becomes really important. So equipment makers and vehicles need to be able to talk with a range of other providers. And to do that, standardizing the rules becomes very, very important. So the standards have a fair amount of flexibility in how they're interpreted. And so it becomes important to be able to agree on how we interpret those standards and how we communicate. We're building out from our previous activities into new applications, including emergency services, notifications, and public transport warnings. So this will build on the understandings that we have from our work in Japan, and we'll show ways in which we can implement those warnings in Australia. And the information that we get from these trials will contribute to two major activities. First is to inform the business model for CITS. So being a very complex stakeholder group, the justifications for each of those stakeholders to bring this kind of technology to production can vary quite significantly. So what it means for us as a vehicle manufacturer and distributor to implement CITS in terms of the benefit that we can give to our customers and our guests, and also for ourselves as a corporate entity, is quite different perhaps from what the benefits might be for a state government or a federal government or a road authority or a roadway operator. So our contributions have been hopefully informing that discussion. And also to progress road safety research. So our data sets are going to be shared in a way that will allow safety research to continue from the point of view of new data sets and being able to analyze those for to gain new learnings. And so we're doing that by contributing to Lexus RX 450h vehicles equipped with an ITS G5 CITS station integrated into the vehicle. It's a similar system to the one that we used in Queensland with updated firmware and software. And we are also creating high definition MAPM content and standards for the AIMS ecosystem. So we are creating high definition MAPM for that AIMS precinct. And Mario will take in a bit more detail about that. So this is happening at the moment. We've been working on that in the AIMS precinct since February this year, and we'll be continuing until February 2022. So about a 1 year active participation in the AIMS precinct. So what are we actually doing in terms of use cases? We're looking at advanced red light warning, which is a warning that you are going to run through a red light. So it's not a warning that other people are going through a red light or that kind of thing. It's a warning that you are, unless you change your vehicle's behavior, going to go through a red light. Turn warning for vulnerable road user, where a pedestrian is detected on a crosswalk, either by a push button request for a signal or through a detection from a camera or some other method. We're looking at that in the AIMS precinct. Road hazard warnings, back of queue warnings, in-vehicle speed warnings and roadworks warnings are deployed out through the Queensland Transport and Main Roads back end, which is similar to the one that we were using in the Queensland CAVI trial. We've done some work on ingesting data from the Victorian data sources, and again, Mario will talk a bit more about that. Two use cases that we will not be testing on public roads at this time are emergency electronic brake lights and slower stopped vehicle warnings. We have extensive history with those use cases that are already demonstrated on test track environments, but also in the real world. Emergency electronic brake lights, it does exactly what it says on the tin. If someone is braking in a connected vehicle in front of you very hard, you will receive a warning that that vehicle is in front of you braking hard. It's not safe or appropriate to do that on public roads, and so not going to do that. And similarly with slow stopped vehicle warning, the potential hazards of testing that in an urban environment such as Carlton outweigh the benefits at this point. We are extending out into 3 new use cases. Those are intersection movement assist, which is a warning that you have a collision risk with a vehicle also approaching the same intersection. That will be a fairly lightweight implementation, and we're unlikely to publish a white paper on that use case. We are also working on tram awareness, which is a warning around collision risk for turning right in front of a tram. About 70% of tram vehicle accidents or incidents are related to a car turning in front of a tram, and so we're implementing a warning to allow the car driver to receive a warning that they should not turn right in front of that tram. That one will be the subject of a white paper into the future, and as well emergency vehicle notifications. So the alert for a car driver that there is an emergency vehicle in the immediate vicinity, and we're working with Ambulance Victoria on that, but we're also in contact with Fire Rescue Victoria and some discussions in that as well. And we'll be looking to build out from those notifications. We're potentially working on some passenger alighting warnings for trams as well to reduce pedestrian and vehicle conflict. So fair bit going on there. A large stakeholder group is involved in bringing this to reality, but we're hoping that this will create some opportunities for further research. I'll hand over to Mario for the next
Alex,
section.
if you can just progress the slide, that might be easier. Thanks.
Yep.
So I'm not going to give a précis of the actual results of the testing. There is a white paper that summarises that pretty neatly, and you can read that at your own time. This is probably a little more to the point that Alex raised at the beginning of sharing of information. So in the 2 trials that Alex mentioned, the Queensland trial and the previous Victorian trial, we had all sorts of contractual arrangements, which meant that we couldn't share data, and if we did, there were in fact some really complicated things preventing us. What we've done in the AIMS trial is that we're not partnering with government as such. We're not getting government funding or anything like that, and that gives us the freedom to not be bound by some of the contractual obligations, and also the partners that we're working with have been quite obliging. So I just want to cover 3 cases, and then I'll talk about a 4th. And intersection testing is an example where there is a lot of exchange of information. In our case, it's been an intersection that's shown in the diagram between Nicholson Street and Gertrude Street. And what's happening is there's a fairly large transfer of information that's going on. There's a CAM message which is telling you about almost the look at me type of message. We've also got MAPM, which is describing the geometry of the intersection. We've got DENIMS, where there's an actual warning that we want to communicate to people around that intersection. We've got SPATM and IVIM, which is information that's in-vehicle information such as speeds. SPATM at this stage is simulated, and now that's a good thing and it's a bad thing. The bad part first is it's not representing real world, and very gratefully to New South Wales and other governments that's being addressed. And also the good thing is you can't always on a public street hold up traffic just so you can experience a green light or a red light or a yellow light. So being able to simulate means that you can actually do lots more testing. The use cases that we are applying, so of the list that Alex had beforehand, advanced red light warning and turn warning vulnerable road user, which is basically a pedestrian at the intersection. The data that comes from these trials, so everything that the vehicle captures that isn't, tied up in any particular IP, which is most of the data, will be shared with academia, primarily through Majid, but shared for the purposes of safety research, specifically in relation to making judgments on how does ITS actually perform in the real world. In terms of the future work and the sort of things that either we'd like people to work on or the things that we will address ourselves, what we've learned, particularly in our Queensland trial, but it's also become very relevant in this intersection location in Carlton, where the RSU placement or the roadside unit placement actually has an impact, for example, on the distance of where you actually get your first messaging. We want to do live spat integration, and we're very fortunate that that's going to happen. We also want to use camera-based road user detection, which is something that happened in the trial with Telstra a couple of years ago. And as Alex mentioned, and I'll mention later on the final slide, we are looking at the integration of trams. We're very fortunate that there's actually trams going straight and turning at that location. So intersection testing is just being used as a proxy for the fact that it's V2I data. We don't really need a lot of research on V2V. We already understand that really well. But V2I and V2N are areas of interest. So Alex, we might move to the next slide. HD mapping, I know people get upset with the term HD mapping. We're calling it that, but it's somewhere between HD mapping, precision mapping, and 3D mapping. But essentially, our ITS use cases, especially the last two that I spoke about, advanced red light warning and the vulnerable road user, is reliant on lane level accuracy. Some of that is for really operational reasons, but others are to make sure that the user experience is relevant. So there's no point when there's a right turning lane to tell everybody in the at the stop line that there's a pedestrian if, for example, they're going left or they're going straight or something like that. So in the last few years, we've actually spent quite a bit of money to create our own high definition maps. And the base precision is 3 to 5 centimetres. And that creates some interesting challenges as well. The diagram on the right or top right is the areas that we've mapped. So we've mapped Laverton, Port Melbourne, Laverton being including Altona, where we have test track and offices. Port Melbourne, which is our head office, as well as Ames. And in total of those 3 locations, 555 kilometres, 215 intersections, 124 road segments, and the locations are just repeated there. Looking at the third bullet point, from the Ames encoder data, what we've done is we've supplemented what we've done in the previous mapping work to include lane centres, stop lines, parking lanes, parking bays, tram and vehicle separators. So this is a scenario where there's actually like a concrete curb between the tram and the carway, tram, bus and bicycle lanes, and connections between the lane and what the ID of that intersection is. So anyone who looks at the cost data from BIC roads will know what that means. What we have discovered in using HD mapping is that there's quite a few issues. One of them is that we have messages that are beyond the typical 1.4 kilobyte limit, but together with our partners, we are looking at the fragmentation of that data. And the other thing is the way that RSUs and OBUs interpret that data leads to some cumulative errors. It's an issue with the ETSI standard, and we're providing that data free of charge to AIMS members. This is the MAPM data, and we're providing it in a way that those cumulative errors don't cause any issues. So it does make the file size slightly larger, but we've created these maps because in the future we do want to do automated vehicle work, and therefore we do want to capture stuff as accurate as we can, notwithstanding that roads always tend to get changed. And we're also looking at trying to explore further the data fragmentation, solving those coordinate projection issues, which are a relationship between the Australian map grid and other projections. And we want to standardise the map encoding, which is the inclusion of all that lane and other types of information, so that it's usable for multi-parties. It's probably hard to see, but on the bottom right with the orange dots are the actual bits of encoded information for just one intersection, and the process of creating that is shown at the bottom there. The next topic is positioning, and it's almost pointless having high definition mapping, but really, really poor positioning. And so this has been a really strong area. We've been very fortunate in that the Australian government and the Japanese government have agreements in the use of the Japanese satellites. And obviously we use more than just the Japanese satellites, but what it has meant is we've been given access to some really, really cool prototype equipment. And I guess if the agreement wasn't there, we probably would have been relying on less sophisticated equipment. I'll just jump to the first point. Probably the two biggest challenges for automakers are infrastructure and positioning. Right now, we can see how an infrastructure solution can come about. It's difficult. It does require huge investment, etc. But the positioning solution is a very, very big challenge. And one of the things that we found in moving to the Carlton environment compared to Ipswich and Altona is just the fact that foliage and buildings and other things tend to obscure the position of the vehicle. The positioning data in terms of what we've captured in the AIMS part of our project, so the one that's less restricted by IP, that is again available for research and for people to look at the problems that we've discovered. So very pointedly on the right are two pictures of essentially the same road. It's Nicholson Street. One of them happens to be a bit north and one of them a bit south, but the point there is that Nicholson Street on the left has got evergreen trees, and you can see by the red and the orange, whenever you know red and orange to be good, that causes quite a challenge. And then when you look at the southbound portion, which is on the left side, you'll see that with the exception of some trees and sometimes even small trees, the positioning is great. And so the research really understanding what the impact of that is to use case delivery, but also from an automaker's point of view, we've done a very extensive positioning trial before we joined AIMS, where we had $90,000 equipment strapped to our car. What we find is that when you use military grade stuff, it works. Convincing a customer to pay $90,000 just for the positioning of their ITS doesn't work. So that's really one of our challenges. Obviously, RTK is a bit of a help there, and we are trialing some new systems, and we're actually, I guess, thanks to AIMS, doing testing of that today. I'll just move to the final slide, and that's just touching on, and Alex sort of broached the topic of trams. Through our partners here at Trams, we've got some really good statistics about what some of the issues are between conflict of whether it's cars and trams or cars and people getting on and off trams. And so as part of our research, and very soon and probably more restricted by driving and the availability of equipment on trams, but we're in a position that we've got software to confirm, for example, cars moving in front of trams, people getting on and off trams when the doors are open. Alex mentioned the emergency service vehicles. Our kickoff is with Ambulance Victoria. They've been very obliging, and we're potentially going to consider the fire services as well. In terms of the other bit of research that is a bit lacking, and that is the information, the live traffic and hazard information coming from the different sources, whether it's private or government. You'll find that every car has, for example, some notification of accidents and things like that, but not in the sense or the fidelity that we require for CITS. This, we think, is going to be a very long-term problem to work on, but a very relevant term, because that is something very key in NCAP. Rural solution, we haven't had any go-aheads or approvals of this one, and we are a bit jealous of the city project in New South Wales having this feature, but with 65% of fatalities being outside the capital cities, it's really important that we look at solutions to address that. We know that at the time of the Kerang disaster, where there was a collision between a truck and a train, there was a lot of interest in that, and we do want to pursue that. So I'll leave it there, and Alex and I are happy to take questions. We're not hearing you, Ian.
Yeah. Off mute helps. Thanks, Mario, and thanks, Alex. You've been doing, I was going to say a truckload of work, but actually just a lot of carloads of work. It's really, really good stuff. We're a little bit pushed for time, but I'm going to squeeze in a first couple of questions. So perhaps the first one to you, Mario, or perhaps Alex too, as you think about giving drivers warnings of hazards and alerts to things that are happening in front of them, there's clearly a balance has to be struck between too many alerts and not enough alerts, and that's partly a question about false positives and false negatives, but it's also partly a question about drowning the driver with sort of alerts to stuff that's perhaps coming, but not really serious. So how are you addressing this question of the level of alerts that you generate?
Yep, I'm happy to jump in for this one. We've found through our initial trials in Queensland that drivers prefer to have only one thing to deal with at a time. Any more than one thing happening leads to dithering and a bad outcome. So the other thing is that the data that they're showing in front of them on the screens has to match the real world. So if you're not matching the real world, the trustworthiness of the system disappears and the drivers will turn it off. Also, you can't just be tapping them on the shoulder all the time, because that gets annoying. No one wants that. So within that though, you can still make decisions around what's a good warning to present the driver in any given situation. And you can make a judgment, for example, if they've turned the right-hand indicator on in a right-hand lane with a tram next to them, they shouldn't be turning right. And that's the most important thing for them at that point, that the car can tell them. We're really at the first rung of the ladder, where we're getting the information to be exchanged between those vehicles. What we do with that as a car manufacturer depends on what else we're doing with all of our other advanced safety systems and the human-machine interface overall. Similarly, that information exchange is then usable in other vehicles. So, trains, trams, and so on. But for example, if you're warning a train about every vehicle that's nearby it, it's irrelevant. They don't need that information, and that judgment is for a train operator to make. So we're at that point where we're bringing that information into into front of those the people making those decisions, I suppose.
Super, thanks, Alex. That's really great. So the next question I'm going to go to originated with Jamie Smith, but I'm going to kind of add a bit of a spin to it. So we normally think of V2I as the vehicle communicating with the roadside unit or the local infrastructure and passing messages back and forth. But could you comment on the possibility to use the vehicle itself as a roadside unit? to be part of the message broadcast network in a more dynamic and comprehensive way, so that you could get loosely better coverage of events and better coverage of messaging, particularly in an environment when penetration levels are quite low. What's Toyota's sort of take on the use of vehicles as a roadside unit, and how do you define the boundary between what's the responsibility of a roadside unit and what's the responsibility of a vehicle?
That's a marvelous question, and we could definitely talk all day about that. I think the potential exists within message standards and use, the standards around the use of those messages within CITS at the moment to allow store and forward of messages and so on. The reality is that in Australia we have a very large extra urban area which is covered by mobile networks, but it's very spare in terms of what's available with roadside infrastructure. So you may, for example, receive a message around an incident via one access technology, so ITS-G5. You would then have that message within your system and the ability to forward that on in some way. The mechanisms for doing that are complex, and they become very, very the more vehicles you have, the more difficult it gets to understand what that looks on a scalable system. At the moment, it's not something we're looking at, but we're looking at having those two connectivities as something that we can look into. So on the face of it, we're still technology agnostic in terms of how we achieve these use cases. What's important for us as a vehicle brand is that we're able to deliver that benefit for our customers and for the road network. So it's a very, very interesting idea, and certainly one that we're interested in.
So,
Mario?
The multi-hop technology is essential. If you can have cars within 500 meters or a kilometer of each other, and they're able to relay that message, at least you're using you're creating a situation where you don't need as many RSUs to be initially installed. So that's definitely something that we want to do.
And so the next question kind of is drawn from some of the comments that Majid and Nima making about the benefits that can be obtained, particularly safety benefits from penetration levels of 20% or more. Mario and Alex, what does Toyota think about the prospects of retrofitting at least the connectivity functionality to even just to Toyota vehicles, for instance, as a way to rapidly increase the penetration and therefore generate higher levels of benefits in the short term?
Yeah, so we've actually studied that point and spoken to one of the governments on that particular issue. I think the key element is the cost of doing that, and also there's a diminishing number of use cases that can actually take advantage of that. There are some systems that are well priced, but for a consumer, they want to, for example, if they're going to pay a certain amount say $1,500 all up, that they're actually interacting and getting benefit of that system at all the time. So not just, and this is an OEM issue as well, not just that things work in Ipswich and in Carlton and Western Sydney or Illawarra. If you're paying that amount of money, you need that benefit, and that's usually where this becomes very difficult from a business case point of view.
Appreciate that. So I'm going to try and squeeze just a couple more quick ones in before we go then to Dr. Peter Sweatman. So the next one is from Hussein Passer, and it's a bit of a more technical question, but is SLAM, which is simultaneous localization and mapping using computer vision and feature mapping, also what Toyota is looking at for accurate positioning? I think that, so are you looking at SLAM as adjunct to your positioning technology?
Don't know about the actual acronym, but the sensor fusion in terms of what particularly vehicles that are much more automated are able to, first of all, capture, but the other is to integrate that with existing information is actually really important. And the vision of not just Toyota, but many car companies is that these vehicles will be creating maps as they drive. And essentially that'll be what is in the end fed to other vehicles. But the 2 to 3 centimetre positioning, as opposed to typically a metre positioning, doesn't allow that sensor fusion to happen, accurately. We're not the experts on this. Certainly, Toyota Research Institute in the US is, but that's one of the drivers for high precision mapping.
Thanks, Mario. Nathaniel Tan has asked whether we could apply the CITS to trams in the reverse sense of giving trams warnings of adjacent or cars on a conflict path. Mario?
Yeah, this was our, I guess, our pitch at the beginning of the program to the bus companies. And there's a particular reason that we're not doing buses, but we thought it was much more useful for a bus driver pulling out, for example, onto a road to have something which is indicative of all the vehicles that are around them. Frankly, it was more useful to the bus driver than the actual driver of the vehicle. One of them can see a fairly large object, but the other one is trying to see in their mirrors all these motorcycles and other things that could be quite invisible. So that's a really good suggestion.
Thanks. And then the last one, which I'm going to turn into 2 questions. So one is, are there sort of privacy and legal issues around the use of connected vehicle data? And I'm going to double barrel that with another question that came in advance, which is, so is any of this information that's generated through CITS sort of relevant or important to the National Freight Data Hub? So it's a question about the use of data and its privacy and its other applications.
Well, can't answer the second question, but on the first one, and obviously there has been discussion with governments, but in terms of the interception of those signals, etc., it's important that we make sure that they're as protected as or the work that's ongoing in Europe. But the other thing is that we don't want this to be a proxy for end-to-end tracking of the driver. So basically an identity change every so many minutes, etc., is what we would favour. There's other systems that are probably more in that vein than CITS. But CITS, it's important for us that we have that that certain level of anonymisation, not complete. If a vehicle is inerrant and putting out, for example, kilometres per hour instead of miles per hour, or the other way around, that needs to be tracked down. But when it comes to the exchange of messaging, the other elements, we're not interested in tracking. We just want to make sure that in the proximity of an intersection and other cars, that people can get safely through that. And if they've done that, well, we can forget the rest. In our trials, we necessarily do things to make sure that we record everything, because we're trying to analyse it, but that's not what we're trying to do in production. That'll just drive people away from the technology as well.
If I can just add just a little bit to that, it's very important that users of the system as drivers view the system as secure, safe and credible, and they need to know that they're not being followed at all moments. And so that anonymisation of the data is extremely important for maintaining trust in the system. If people think that they're going to be, that they're going to have their location history rummaged through in the future, they will not feel comfortable using the system.
Indeed, trust in the system and credible and informed use of the data is going to be key. And that's a very nice segue into our next speaker. So Dr. Peter Sweatman, who's Enterprise Professor in Transport Technologies at Melbourne Uni, and a long time engagee in CITS, both here and overseas. Peter, I think you're going to talk about some of the opportunities for using this Lexus data into the future.
Indeed, Ian, thanks very much, and good evening to everybody. It's great to be with you, and it's been a seamless cavalcade of information so far, so I'll try and keep that up, but I won't go on too long here. So what we're thinking about is here's an opportunity to leverage the project, particularly the Toyota Lexus project that Mario and Alex just talked about, and using that data which is being made available. So, and I'm going to dive right in on safety. So some of us have been involved in safety research for a very long time, and I'm one of them. So we just need to remember, and I think Majid mentioned this earlier, that more than 1,000 people still die from road trauma in Australia every year. And we need to realise that that's been going on for 100 years. It's one of the amazing statistics to me, and it's the same here in the US, that that number, except it's 40,000 here in the US, but that number hasn't varied that much. It went up a bit during the 70s and 80s, and then it sort of dropped back down again, but it's kind of plateaued out. So a lot of work has gone in to improve safety. You know, it's an ongoing battle the whole time, policy, research, technology, and so on, many decades, probably, let's say 60 years, 6 decades of significant safety work. But recently the rate of improvement has slowed significantly. But now we have technologies that can really sense imminent crash risks pretty close to the crash, with advanced sensing, connectivity, and automation that's been talked about a little bit. So there's no doubt CITS can help us with those crashes and create alerts for the drivers and possibly more. Thank you, Majid. And I guess the way I look at it, looking back over those 60 years, we've had global waves of road safety. We've had long-standing disciplines in the safer vehicles, first of all, passive safety, active safety, and so on, driver behaviour, compliance enforcement, traffic control and infrastructure. All of these things have, in a somewhat independent way, contributed to improvements, big improvements, because bear in mind that the kilometres or miles of travel have increased dramatically. So while those fatalities have been the same, the rates have reduced to a great extent. And more recently, we've had a deeper understanding of how interactive this environment really is with safe systems. And to a large extent, that has a pre-crash kind of sensibility. Upstream of the crash, if you get too far upstream from the crash, then it's hard to predict what the benefit's going to be. So where we are now in the future, right now and into the future with this CITS, is to enable what I'll call a safe ecosystem with connectivity and automation, and we get much, much closer to the crash. Thanks, Majid. So the data that's being made available by Toyota Lexus through AIMS pertains to the testing that's been done. And I want to mention CAPS, Traffic Com, WSP, Victorian Department of Transport, and of course TMR, who really got this ball rolling in Australia. And let's call them the Ipswich set of messages. And we've already heard about those, so I won't dwell on that. We don't have a lot of time. Thanks, Majid. But that's what the data pertains to. I think the HD mapping, and Mario dwelt on that nicely, is very, very exciting, because the immediacy of these warnings and the crash imminent warnings is increased dramatically with HD mapping. So wonderful advances. It's been fascinating to me to see the use of the TMR central facility to do stuff in Carlton and Fitzroy in Victoria. So we could simulate traffic situations in the central facility at TMR and inject them into the vehicles within the AIMS testbed. So this augurs well, I think, for a kind of a joined up approach to the implementation of CITS. And also the integration of state DOT data. We've mentioned TMR and VDOT, but also New South Wales as well, where it's very pleasing to see all of them coming to the party in slightly different ways. Thank you. So we've put our heads together and we've come up with 6 possible opportunities for taking advantage and leveraging this Toyota Lexus data in the AIMS testbed to really move forward the safety and traffic aspect of CITS. And, you know, it's a chicken and egg problem where what do we do first? And it's been said a couple of times that we're dealing with a system, and which part of that system do we start with? So I'll just quickly mention them and then I'll summarize them very quickly. Safety benefits for the Australian network. So how do we make it an Australian approach? Traffic network optimization using CITS data. So now we're talking about traffic efficiency. And you already saw some very encouraging work from Majid where the two aren't opposed to each other, safety and traffic efficiency. What can HD mapping infrastructure do to really supercharge these CITS applications? Use cases with public transport vehicles. So there we mean trams, buses, trucks, larger vehicles, slower moving vehicles, vehicles that don't normally have a good safety mix with lighter vehicles and particularly with vulnerable road users. HD mapping and CITS for regional scales in the rural network. And I would remind you of the, I think Mario or Alex just mentioned that 65% of fatalities in Australia are not in the cities. So we must be doing something about that. And the effectiveness of CITS for vulnerable road users. So let me move, they're the 6 potential projects that we've thought about. If we could go to the next one, please, Majid. So here's a little summary. So I've numbered the same numbering, but I've given them a very short title: safety case, traffic impacts, HD mapping case, what additional things can we get from that? Embracing the public service vehicles, regional rural deployment, and a focus on vulnerable road users. And then the next column could be up for grabs, and this is just indicative, but it's something we need to think about. What's the maturity of the work in each of those areas? Now, you know, I'm sure Alex and Mario, I haven't run this past them, so they might have totally different ideas about this, but we do need to think about that. And what we're hoping after this workshop is that you'll all think about this, and we'd love to get some feedback from you about which of these options you think are the most important to proceed with soon. And we'd love to get that feedback. And maybe, Ian, we can think of a way to kind of semi-formalize that feedback process after the event. And now I've got a column there called X Factor. So, you know, what is the really exciting and compelling thing about each of these? So in the first one, kind of a no-brainer, it's the next wave of traffic safety, the safe ecosystem via CITS. The second one, to me, we're going to put traffic sensors in motion. So at the moment, we're trying to understand traffic from a whole lot of static sensors around the network, each of which are pretty blunt objects when it comes to what they can see about vehicles. Imagine if that information, or at least a lot of that information, or part of the information, was coming out of moving vehicles. That would just make a tremendous difference. In the HD mapping sense, it's the ultra high fidelity sensitivity to immediate crash risk. So when we know where all these important lane lines are and stop lines and so on, and actual concrete objects that don't show up normally, then our crash fidelity is much, much better. So that's a very exciting area, and probably relatively little been done on that. The public service vehicles, so we want safe harmonisation between smaller vehicles, vulnerable road users, pedestrians, cyclists, and some people on electric scooters, with large vehicles, whether they're trams, buses, trucks, and so on. And then, of course, the challenge with regional and rural deployment is preventing single vehicle crashes, which most of them are. And the focus on vulnerable road users really is all about people-centric traffic control and driver awareness. So we need to do a much better job of detecting people in and around urban intersections and giving that information to drivers. So there's a very quick journey. We've got better write-ups of all of these possibilities, and we'd love to share that with iMOVE members and iMOVE in general, to the extent that there's an interest in trying to pick up and leverage some of these projects. And I think I've got one more slide, Majid. So, you know, our vision is a safe ecosystem for 21st century mobility, involving state DOTs, the Transport Accident Commission, federal government, ITS Australia, Austroads, NTC, and then, of course, most importantly, critical segments of the private sector. And when we thought about it, and we thought about those particular options, ITS, insurance, telecommunications, motoring organisations, traffic control, autonomous shuttles, automotive, and information technology. So we see a role for all of those to be involved in some or all of these projects, and we would really appreciate your help to parse them out and see a way that we can make a start. Thank you, Ian, and thank you all. Happy to take questions.
We can't hear
Ian,
you.
you're on the mute.
Sorry, Ian, we couldn't hear
that. It helps. So thank you, Peter. And in fact, while you're thinking of your questions to ask, I want to add a special thanks to Peter, because unbeknownst to you, Peter's actually been presenting to us from the US, and anyone that's got any understanding of time zones will realize that it's just actually a horrible time of night to be presenting to Australia from the US. So thank you, Peter. We really appreciate the personal effort that you've gone to share those insights with us. So speaking with those insights, most webinars finish at the closing time, and this one will finish at the closing time too in a few minutes. But in this particular case, we're going to follow up. We're going to follow up with an email in which we will share with you both access details for the white paper that I think it was Mario spoke about earlier, and we're going to invite you to respond with your interest in the various project ideas or areas of further exploration that Peter and the other speakers have been suggesting to us. So now, how are my questions going? Yeah, so we've got one here. So it's a question about deployment of CITS, and so Andrew Watkins is asking, is it better to do this to introduce CITS in a sort of gradual stepwise fashion, or somehow wait till it's ready for harvesting and then deploy it sort of everywhere? What's the best deployment path for CITS technology? Who would like to take that one on? Peter.
The best way would be to have legislation so that all vehicles have the technology and have some investment in the infrastructure. And the investment is not as horrendous as sometimes thought. But barring that, barring a miracle like that, then I think we've got to come down to some selected applications. And, you know, I think the set, what we call the Ipswich set, a pretty good one. And I think it's important to remember that you need a mix. So serious crashes and fatal crashes are very rare events. So hopefully, if you have a vehicle equipped with this technology, you're not going to see that very often. So there has to be applications that provide useful things that relate to driving comfort and so on, and are safety relevant, but they're way upstream of any crash occurring. And hopefully, you know, it's going to help prevent that crash. So I think that side of it's really important too. And that's why I think the Ipswich set are a pretty good mix, because there are some of them in there as well. And there are some, you know, areas like for Melbourne, I always feel that CITS applications or use cases are very location specific. So, you know, you might go to a city where it's a huge problem that people suddenly open car doors and cyclists ride into the door and get injured. You know, that happens in certain places. Or it might be wrong way entry on freeway ramps. So, you know, I think we need to be very conscious of the local character of this. And so I'd like to think that, you know, obviously we need the standards for the vehicles, and we've seen with our work here, the great cooperation between the 3 eastern seaboard states on the vehicle side. And I think we're seeing that too with what gets deployed in the infrastructure. And then the use cases can have a very local flavor and make it very attractive for local deployment. So it's not a mandate from Canberra that says you must do it this way. So I think it's that combination of standardized platform and very appropriate applications for wherever they're being deployed.
Thanks, Peter. Does anyone else want to add to Peter's comment?
Yeah, certainly. The phrasing of the question is very interesting. Implementing features is a good way to look at it. So there's a very large range of technologies, data streams, and I mean that in terms of both infrastructure, you know, back end, in the vehicle, on the roadside sort of thing. We prefer to think of it in terms of what we can offer the driver of the vehicle, but it's also what then the actions of the driver then give back to the system, and the data that you can exchange between those things. And that in the next couple of years, we are going to see a rapid rise in the deployment of connectivity in vehicles. And I think that if we have the data streams available to do some of these applications, yeah, we'll be able to do some of these things. And I don't think it makes any sense, if there's a safety benefit, to delay implementing some of these technologies where there's a potential safety benefit.
Thanks, Alex. And I would add to that it's pleasing to report that I think there's a strong appetite amongst the jurisdictions to come together to resolve the, shall we say, the standards or the interpretation of the messaging standards that is going to apply in Australia. That process it's not complete yet, but I think there is a wide recognition in the state departments of transport that it's going to be best to have a national approach here, and they're willing to sit around the table to kind of work out what that national approach is going to be. And so, you know, at some level, this webinar is also an appeal to state departments of transport to start thinking about how they might benefit their local communities from progressive engagement with CITS, development of data streams, availability of data, and improvement of safety.
I do actually just want to quickly add one more quick point.
Yeah, please.
That question of implementing now, the work that we're undertaking at the moment is a part of that pathway towards implementation. So it's not, you know, can we do it like now, today? We're actually engaged in that work as we speak. Whether that results in an application in a vehicle in front of a driver in a particular year is hard to say at this point of the development pathway. But we're actively investigating those things right at the moment. And yeah, the state government's involvement in those data stream preparations is very encouraging.
Thanks, Alex. So I think we've come to the end of our session. So it remains for me to thank you all for your participation, thanks to the speakers for their hugely interesting presentations, and for the huge amount of work that's gone on in recent times to generate the learnings that you've been presenting. I invite all of you to make contact with us after this event with your ideas, your thoughts. We will reach out to you in any case with a sort of, to invite you to respond to Peter and the presenters' ideas for future projects. And I would invite you to follow iMOVE on LinkedIn to find out about further webinars and discussions that we're organising on CITS and other things. So with that, I say thank you all for your participation. Thank you, speakers, for your great contribution. And we look forward to seeing you next time. Thanks very much.